Greeting, I am Anil Bode from Pune Institute of Computer Technology, Pune. Welcome to the course on Basic Electrical Engineering. In this lecture, we will cover the second part of construction of transformer, that is transformer tank, terminal bushing, conservator, breather, Bocuse relay and explosion vent, as we already covered the first part of this in our previous lecture. After going through this video, you will be able to explain the construction of transformer. So, we will start with the transformer tank. Transformer tank is used only for big size or big capacity transformer. It is not used for small size transformer. The whole transformer assembly is placed in a fabricated sheet metal tank and immersed in the oil, which serve both the purpose of providing insulation and cooling. The heat generated in the winding and the core of the transformer is carried by the oil to the external surface of the tank, and the cooling tubes are provided to increase the surface area of the tank for more effective cooling. Now, terminal bushing. The lead of the transformer brought out from the tank are insulated from it, means tank, with the help of porcelain bushing. These bushing are fitted to the tank. Now, conservator tank or conservator. This is a airtight cylindrical metal drum mounted on supporting structure on the roof of the transformer main tank. This drum is connected by a pipe to the transformer tank and is always partly filled with oil. It's provide mainly two purposes. Number one, it's provide some space for the oil to expand and contract when change of temperature change of temperature occur in transformer. Here please note that during expansion and contraction of oil, the main transformer tank must be fully filled with the oil, and for this purpose conservator tank of the transformer act as a reservoir of the oil. And second, it's avoid the direct contact of atmospheric air or moisture content to the transformer oil. In our first point, we discuss about the change of temperature and expansion and contraction of oil. So, question is why the transformer temperature is changed and why the expansion and contraction of the oils occur? And the answer is it's all happened due to the change in load of transformer which is connected to the transformer terminal. Let's elaborate it. Transformer secondary current depends on load. Transformer secondary current depends on load, and the transformer load is never constant. Because of this varying load, transformer secondary current is also changed, and hence the power dissipation in the form of heat occurs, and accordingly temperature change occurs in the transformer. When the transformer becomes warm, oil expands and the air at the top of the oil is expelled through the breather. When the transformer cools, oil contract oil contract and The outside air is drawn into the transformer through the same path. This process is called the breathing of transformer. Means means in and out of air in conservator tank is known as breathing of transformer. Now, breather. The breathing process of the transformer is take place through the apparatus known as breather. It contains a drying agent such as calcium chloride or silica gel which extract the moisture from the air. The breather also clean the air by removing the dust particle present in it. Thus, only dry and clean air is allowed to come in contact with the oil in the transformer. Next, Bocuse relay. Okay, so it is a type of protective device mounted in the pipeline connecting the main tank to the conservator tank. Due to the excessive heat developed during the fault condition, the oil in the tank in the vicinity of the fault point get decomposed and different type of gases are liberated and different type of gases are liberated. These gases operate the Bocuse relay which in the initial condition give the alarm to the operator. If the fault develop is converted into a series type of fault, then this relay trip off the main circuit breaker. Now, explosion vent. The vent up pipe fitted on the upper surface of the tank is known as the explosion vent or relief valve. It is provided with a diaphragm made up of glass sheet, aluminum foil or bakelite sheet. In the event of the fault condition, if the excessive pressure is developed inside the tank due to liberated gases, the diaphragm in the explosion vent burst and release the pressure, thus avoiding the damage to the transformer. Thank you.